calculus students, this is Kim Breeden. In Chapter 1, we did a brief overview of limits. Chapter 2, we dig into this in more depth. I think it's easiest to start with an informal idea of limits. Basically, a limit is when we get really close to something. We can't actually get there, but we know what it should be just because we get really close. And we use limits for a variety of reasons. As you'll see today, we're going to use them if we have a hole in a graph, or if we have an indeterminate or an undefined value. I found some great slides from Meg Craig, whose philosophy of explaining limits I really liked, so I have to give her credit for the upcoming couple of slides. So imagine we have that f of x function graphed. Now, look at what's going to happen if we evaluate f of 2. If you put 2 in for x, you're going to end up divided by 0. We can't do that. So if our aunt is trying to walk to the point where x equals 2, she can't get there. However, she can get really close to that point, so we could predict what it's going to be. That's a limit. And we can go ahead and we can check this with a table. Now with limits, we're going to look at which direction the aunt is coming from. So we're going to start with our aunt approaching from the left. And you can see we evaluated this function for values that act closer and closer to 2. So 1.99, 1.999, and so on. And you'll notice that as x gets closer to 2 from the left, our f of x gets closer and closer to 4. That's considered the limit. Here's how we'll write it mathematically. So this means the limit of our function, x squared minus 4 over x minus 2. The bottom here, as x approaches 2, notice there is a negative sign above that 2. That means we're approaching from the left. And that equals 4. So as we get really close to 2 from the left-hand side, we're going to equal 4. Again, it doesn't matter that we had a hole when we actually looked at the graph. So looking back at the same graph, imagine this time that our aunt is walking from the right. Again, she's going to hit that hole. However, if we look at the table, we can put in values for x that get really close to 2 from the upper side. And you'll notice as that happens again, we're going to get really close to 4. So we can assume that as x gets really close to 2 from the right-hand side, it's going to approach 4. Again, the way you're going to see this written in your textbook, the limit of x squared minus 4 over x minus 2 as x approaches 2 from the right is equal to 4. Now in this case, the limit from the left and the right ended up being the same value. We'll explore more about this later on. But in order for a limit to exist at a point without the left or the right, we do have to have those two limits to be equal. So as we look at our definition of limit, a couple key things to remember is that we're approaching A, and we can approach it from either side, the left or the right. As we do that, it gets closer and closer to our limit, our value L. Now, our left and right limits may not be the same, and we'll look at that more in upcoming assignments. But if the left and right limit are not the same, we say the limit at the whole number does not exist. And don't let f of a concern you. The actual value of f of a might not equal our limit. It might not even exist. Okay, but that doesn't impact our limit. Let's look at a couple examples. So your assignment will have you looking at different graphs. So again, part of the lesson is understanding the terminology. So our first problem on the right says we want to find the limit of f of x as x approaches -4 from the left. Now if I just go ahead and I look at -4, I notice that there's a hole there. Okay, that doesn't mean that my limit does not exist. We're this time looking just from the left. So I'm going to trace out from the left, and I'm getting closer and closer. And the closer I get to x equals -4, I'm going to get really close to 2. So my limit is 2. Now let's see what happens if I approach -4 from the right-hand side. So I'm coming in from the right, I'm going to get closer and closer, and the same thing's going to happen. I'm going to approach 2. Because my left and right limits as x approached -4 were the same, I do have a limit as x approaches -4, and that limit is 2. Let's try another one. Let's find the limit as x approaches 1 from the left. So coming in, x approaching 1 from the left. As I get really close to x equals 1, my limit will be 4. Now we want x approaching 1, this time from the right, from the positive side. So now I'm down here. As I get really close to 1 there, my limit is going to be -2. Now it doesn't matter that f of x doesn't actually equal -2 at that point, but the limit as x approaches 1 from the right is -2. You'll notice that my limits from the left and my limit from the right are not equal. That means that the limit as x approaches 1 does not exist.